Good morning, everyone. This morning I will present the paper with the title Combining Blockchain and BPMN Choreographies for Construction Management. Process modeling is fundamental for efficiency and quality in management. Nevertheless, in construction industry, it has not the same weight as product design, and it is still poorly integrated in the whole sector management. This is so true that even the most recent BIM approach, which would be in charge of driving construction work processes towards a greater level of efficiency, does not have an expressive formalization of processes, and this makes it necessary the link to other methods and tools with interfaces possibilities. In the construction sector, the recurring formalization are that of network diagrams, such as, for example, CPM or PDM, that provide for a static articulation of reciprocal relationships. Things don't change using the business process modeling notation, the BPMN formalization of processes, where the sequences of activities represent a centralized orchestration managed by a single decision center. Actually, there are more than one decision-making center usually in the construction process. This because the typical structure of construction production is the holonic one, with different agents working independently on their tasks. In this kind of organization, a centered coordination is brought into play just in case of problem solving for shared issues. Basically, BPMN has three different ways of representing processes. The first one is the orchestration models, typically depict the coordination of processes from a single point of view. This type of model is therefore appropriate to describe processes with a single business entity or processes where there are several participants but the control remains centralized. Then there are the collaboration models, which show different participants and their interactions. In other words, a BPMN collaboration model is any diagram that contains two or more participants who have a flow of messages between them. Collaboration processes allow participants to hide actual internal processes in order to provide flexibility for internal processes to change without breaking the interconnection. Finally, there are choreography processes, which represent a different kind of model introduced with BPMN 2.0. Its purpose is to purely represent the interaction among participants in a different format than collaboration models, focusing on the flow of messages rather than on a strict precedent structure between activities of different actors. A choreography is a formalization which is able to represent processes where there is no hierarchical organization of coordination and where a central coordination only manifests itself when problems arise. In this kind of organization, every actor has a task, but it has also a decision-making space on when to actually execute that task. In this case, it is almost impossible to think that there is a central coordination of all resources because this would in many cases increase inefficiencies due to delays between data, decision and execution. Managing this data in a complex system creates major inefficiency, and centralized management creates process flooding. Typical management in which you have to perform tasks, this type of organization based on tasks and not on the straight tight time coordination, is in fact the choreography. In presence of several independent actors, choreographic models are considered the most suitable solution to ensure the autonomy of each individual participant in following their internal processes, while maintaining control over the interaction. We have many actors with multi-scene theater. There is coordination, but it is holonic, and everyone with his own processes, most of the time asynchronous. Furthermore, choreographies focus on information flow among participants. The application of blockchain to choreographies, it is useful in order to track activities execution and the specific situation in order to manage issues. This research is focused on formalization modeling of choreographies with integration of a DLT system, such as the blockchain, for tracking of construction processes accomplishment. The original contribution of the work lays in the following aspects. We propose a way of modeling construction processes that best mimics the construction industry structure. Then the work here presented integrates a blockchain service for activities notarization, providing trust between actors and references if responsibility identification is needed. We have focused on supply chain processes in which there are several actors, there are no direct connection, but still information passes even if no sequences is shared. The process of one does not affect the process of another. The link between processes is information, and there are no close coordination links. Coordination is holonic, and it is not an orchestrated process. The concrete casting process has been chosen because it falls under a strict regulation, defining the documents that have to come from the producer, the correct way of forming and maintaining specimens, and the tests that have to be pursued. Moreover, this process is often tainted by criminal infiltrations, cheating on concrete quality. The need for trustful means in order to assure that all the stakeholders have pursued their duties is therefore highly recommended. First of all, in this work, an enhanced choreography mechanism called notarized business process choreography has been defined. It maintains the records of the process's execution on a secure and trust-shared database. In order to define this notarized business process choreography, no extension of the BPMN 2.0 formalism is required, but a supporting architecture is needed with components supporting both designing and execution time. At development time, the following toolchain can be used to create and deploy smart contracts, then used by the execution architecture. This toolchain is developed as follows. The choreography building. It is an optional component that translates a BPMN collaboration orchestration diagram onto a BPMN choreography diagram. It is actually an abstraction process where several operational elements of the BPMN collaboration diagrams are abstracted away, and only the exchange of relevant messages is considered. The output choreography has the property of being realized by the input collaboration diagram. This step is also useful to ensure backward compatibility of our approach and tools with BPMN collaboration and orchestration diagrams that are still used in the construction industry. Then there is the business choreography smart contract generation. It recognizes possible states of a choreography at any possible moments, as well as the tasks that can happen in any such state, and the actors that should execute the task. Such tool takes as input a BPMN choreography diagram and outputs a smart contract written in Solidity or Viper. Then the smart contract compilation. It translates the smart contract into its bytecode to be run by the Ethereum virtual machine that is installed on every node running on the Quorum blockchain. Traditional state-of-the-art smart contract compilation are Solve for the Solidity language and Viper for the Viper language. Then there is the smart contract deployment. It deploys the smart contract bytecode on the Quorum blockchain network. This can be done through popular libraries such as Web3 for JavaScript and Web3 API for Python. In our work, we reuse existing tools for the smart contract compilation and the smart contract deployment. The compiler Solve for the Solidity language and the library Web3 API for the smart contract deployment. But we developed new tools for the business choreography, smart contract generation, and the choreography building phases. In modeling the concrete casting process, at first a BPMN collaboration diagram has been created. Several actors are involved: the works management office, the concrete producer, the building contractor, the laboratory, and the BIM service. Also, a bus pool has been modeled, which is the one where all messages between different actors involved are received and forwarded. It is the one with all the orange parts, the orange messages in the middle. The bus pool was our first modeling attempt of blockchain service. The same process has then been transformed in a choreography kind of BPMN so as to be more focused on the information flow between different actors. In order to allow the enforcement of BPMN choreographies and the notarization of BPMN processes, our execution architecture is built around the state-of-the-art Camunda BPMN workflow engine. By means of specialized connectors, the Camunda engine can interact with smart contracts. Two different connectors are used, one named Enforcer and the other named Notarizer. The Enforcer connector ensures that each BPMN process can send or receive messages in a way that is compliant with the choreography. Basically, the connector intercepts the message through events where a hash of the actual message body is passed, and it generates a transaction on the smart contract enforcing the choreography. The actual message payload transits through a RESTful service. Then the notarizer connector allows a given BPMN process to notarize its tasks. Indeed, before each task of a given BPMN process takes place, a special message throw event is used to trigger the notarizer connector, which in turn reacts by signing a transaction on the notarizing smart contract managing such process. A first test of part of the process on site has been pursued in a construction site near Bologna. In this case, the new creation of concrete sampling has been the process under control. A web application has been developed, and the image you can see from now on are the screenshot of the web application. It gives the possibility of inserting the supplier data, then the concrete delivery information and the pictures of the specimens. And finally, it is also possible to scan an NFC tag to check the identity of the specimen. In the construction domain, work plans are heavily based on several parallel tasks going on by several actors forming a federation according to a construction contract signed by all the parties. While all the tasks during construction phase can be represented by business processes, this scenario lacks a central authority that has the power or the right to coordinate all the involved actors. Our work stems from the simple observation that the blockchain technology is a powerful tool for configuring a distributed system, and since it is based on consensus algorithm, it can ensure that all the nodes of the network can agree on a consistent linear history, realizing a distributed ledger. The information that needs to be securely stored can be divided into two sets. Piece of information relevant to other parties involved in the legal construction contract and internal steps taken by each organization or company participating in the construction process. We claim that the blockchain technology is better suited to enforce the execution of a distributed choreography, and in the future we would like to test the procedure with different processes and stressing it to test the reliability of the whole architecture and system we proposed. Thank you for your attention.